canceled out with this one oxygen here. Hydrogen canceled out with that hydrogen here. No, here. Okay, and water. I don't know where I have water. Water's in the final reaction, so we're good. So everything else should have canceled out. Na2O, that's in the reactants, that's good. So that stays. Water stays. It's not enough room for me to really see this. And everything except for Na2 canceled out there, and 2 NAs cancel out. That's what I was looking for. Alright, anyway, that's your answer. Do I like it? No. Okay. Heat of formation. Every time I see enthalpy from heat of formation, that's delta HF. So I want to find from this reaction, I want to say the delta H of reaction is the sum of the number of moles times my delta HF of my products minus the number of moles times the delta HF of my reactants. Products minus reactants. Easy. Okay, so the products down here, 4 times NO. NO is a 90. So I think that ends up equaling 360 kJs. Okay. 6 times water plus 6 times. Now this water is a liquid. I've seen it before as a gas. As a liquid, it's negative 286. So this is going to be minus 6 times 286. So it's 1716. Now minus 360. So the total of your products is going to be negative 1356 kJs. Okay. Now let's do the reactants. Close brackets. The reactants are NH3, negative 46. They gave me a lot of numbers I didn't need. So this is 4 times negative 46. And an oxygen, not on here, it's an element. Oxygen equals 0. So I can just close it up. I don't have to worry about oxygen. Negative times negative, this will end up a positive. So it's 4 times 46, 184. And add 184 minus 11356. I'm getting negative 1172 kJs. A. Moving on. Okay. Which one's not equal to 0? Oxygen as a gas is 0. Nitrogen in a gas equals 0. How about that one? Fluorine is not a gas. Fluorine's a solid, so the answer is D. Chlorine as a gas equals 0, and carbon graphite is a solid, that's 0. So just the fact that fluorine's not a solid means it's not 0. Okay, what's the standard of heat formation for methane? So we're going to start getting cute. I'm giving you the heat of the reaction. So the thing to do is write down the equation. Delta H of a reaction equals the sum of my number of my delta H of my products minus my N times the delta HF of the reactants. Okay, so this number I know now. What am I going to solve for? I want CH4 right there. So I don't know. The number of moles is only 1. That makes it simple. So I want to find the delta HF of CH4. Okay, that. Oxygen 0. So this is N delta HF of the products. So I'm going to rearrange it to solve for this. So delta HF of CH4 equals, okay, I'm going to take this to that side and that to that side. So it's going to be N delta HF of my products minus the heat of the reaction. So the heat of the reaction was minus a negative 889.1, and now I got to do my products. CO2 is negative 393. There's only 1 mole, so we don't have to multiply it by the number of moles. There's 2 moles of water, and it's 285, so I'm going to add this up to 2 times negative 285.8, running out of room. Total all this up, running into my next problem. Negative 393.3 times 2 times 285.8, and it's got to be negative. That can't be right. Negative 282 times real like when you get that on camera. Are you kidding me? Negative 571.6, and then I'll say minus 393.3. So what I get is I get negative 964.9 minus a negative, which becomes a positive 889.6. So the delta HF for the methane is plus 89.6, 75.3, and that number is negative. Because I bet you there's a positive on the choice. 75.3, 75.8. We'll just go with that one. Close enough. Okay, C. Okay, 36. Easy. Determine the H of the reaction. Okay, here's what's wrong. You have everything listed, but you don't have I2. Well, you would think I2 should be 0, but I2 is not a gas. I2 is a solid. So you need the delta H of the I2, so you can't solve this problem just because the iodine's not a 0. So they played a little trick. You had to look at the states. Alright, so that one's E. Makes life easy. Okay. Again, we're given the delta delta H of the reaction. We want to find the C2H6, and we're given a whole bunch of stuff we don't need. H is 0. C2H4 is what we want to find. No, we notice that that's positive 52.3, so that's given. This is question mark. So I'm going to find the delta H of the reaction equals your delta H of the products minus delta H of the reactants. What I want to solve for is C2H6, so I want to find the product. So I'm going to rearrange this and say the delta H of the product, C2H6, is equal to delta H of the reaction plus, I'll add this, delta H of reactants. Okay, so the reaction is negative 137.0 kJs, and I'm going to add that to whatever the reactants was, which was C2H4, which is a positive 52.3. So I just have to add those up. So my delta H of C2H6 of formation, negative 137 plus 52.3. Looking to me like negative 84.7. And that's going to be KJ's. B. Bond enthalpy, I'm not doing anything past here, but I will answer this one. Making bonds. Making bonds is always exothermic, and breaking bonds is always endothermic. It always takes energy to break bonds. So an exo-endo, C. That's it. Good luck on the test.